Okay, this is 13.6 continued. We're going to look at an example. It's practice quiz 5, number 4. It says find the gradient of the function and the max value of the directional derivative at the given point. So here's a function. It's the ln of x squared plus y squared raised to the 1/3. And our point here is 1, 2. So first thing to note is, using properties of logarithms, I can take that 1/3 in front. So it'll be 1/3 ln of x squared plus y squared. Okay, note then, the partial derivative with respect to x. Okay, so the 1/3 and derivative of ln will be 1 over x squared plus y squared. Multiply by derivative of x squared plus y squared with respect to x. So with respect to x, it'll be just 2x. This then you could write as 2x over 3x squared plus y squared. Also, at y be 1/3 derivative of ln, so 1 over x squared plus y squared times derivative of x squared plus y squared with respect to y this time, so it'll become 2y. So it'll be 2y over 3x squared plus y squared. So now, this applies the gradient then. Well, by definition, that's partial derivative with respect to x and partial derivative with respect to y, j. So our gradient here will be then 2x over 3x squared plus y squared I plus 2y over 3x squared plus y squared j. So that's a gradient. We could actually factor out 2/3 and x squared plus y squared from both of these. So factoring it out, so put 3 over x squared plus y squared here on the outside. Then on the inside, I'll have an x left in the I position and a y left in the j position. Okay, so now we need to evaluate. So let me use this now. So we write up the gradient up here again. So gradient is 2 over 3 x squared plus y squared times xi plus yj. So at the point 1, 2, so point here, we have, so gradient 1, 2, so just put 1 in place of x, 1 in place of x, 2 in place of y, so forth. So it'll be 2 over 3, 1 squared plus 2 squared times x would be I plus y, so 2j. Okay, so simplifying this, that's 4, 5, so it'll be 15, that would be 2 over 15, 2 over 15, I plus 2j. Okay, now we're going to use theorem 12. So by theorem 12, max occurs, so max value at, so max value, I guess maybe more like this actually. we'll go max of our directional derivative equals magnitude of gradient. So in our case, we have to find the magnitude of our gradient at a point 1, 2. So here's our gradient. So the 2 over 15 will come outside. Now the square root of 1 squared plus 2 squared. Okay, so then our gradient, magnitude of our gradient, so that's going to be 4, so 5, so it would be 2 times square root of 5 over 15. So that would be max value. So max of our directional derivative at the point 1, 2 will equal this. Okay, lastly, the direction of max increase will be u equal to, just normalize our gradient at 1, 2. So normalizing that, let's see, well, this guy here is that one's going to do reciprocal because you're dividing by it, so I turn it over to 15 to square root of 15, square root of 5, sorry, times our gradient guy. Gradient is right here, so it'll be times 2 over 15 times 5 plus 2j. People cancel. So it's like 1 over square root of 5 times I plus 2j. So that's a u. So that's points in the direction of max increase. So we're done. So here's a max derivative, and it's the direction of max increase. So we're done.